Alright, so today we're working on 3-4 imaginary and complex numbers. And if you had me for Algebra 1 or IM1, you remember me always saying you can't take the square root of a negative number until Algebra 2. Well, today is your lucky day, because now you're going to learn how. So, imaginary and complex numbers always have to deal with radicals and with roots. So, we know we can take the square root of 36. It's a nice perfect square. And we know the answer to that is plus or minus 6. So the problem comes in when we are trying to take the square root of a negative number, because in order to get to negative 25, I have negative 5 times 5, which by default are not the same number, so I can't take the square root of them. So what you need to know is, and there's a long explanation, but I'll give you the short version, is that we have this number, an imaginary number that we call I, and its equivalent is the square root of negative 1. And by the same turn, I squared equals negative 1. So anytime you see a negative within the radical, you can actually swap that out for a negative 1. So I would rewrite this square root of 25 times the square root of negative 1. And then the square root of 25 is plus or minus 5. And the square root of negative 1, we now know, is the letter I. Okay? Same thing here. I would break down, always use your perfect squares if you can, and make life easier. So square root of 25, square root of 2, that would give 25 times 2 is 50, and then I would add the negative 1 on, because now I can exchange that for an I. So square root of 25 is 5, plus or minus. Square root of negative 1 is I, and then the 2 stays in the radical, just like that. Okay, so let's think about when we expand the powers of I, what happens. So I just equals I, that's fine. And we know that that's the square root of negative 1. If I square 2 of those, then what I have is I squared equals negative 1. We know that to be true. If I have I to the third, I really have those first 2 multiplied together, because I squared times I is I to the third. So I times negative 1 would be negative I. And then I to the fourth would be I squared times I squared. Well, I know that that's negative 1 times negative 1, which would give me positive 1. If I continue that pattern and go over to I to the fifth, I really have I to the fourth times I. And my I to the fourth I figured out down here is just 1, so 1 times I is I. And we're back. Okay, so then I to the fourth would be, I to the sixth would be I to the fourth times I squared. If I go and look back over here, I have I squared is negative 1 and I to the fourth is 1. So that also gives me negative 1. What you're going to see is this pattern of these multiples of 4 repeat over and over. So the easiest way to figure out what a power of I is going to get you is to divide this exponent by 4 and figure out where it is in the pattern over here. And you're going to see that by the remainder. So 15 divided by 4 is 3 with a remainder of 3. So for I to the 15th, I'm going to look at I to the third, and that's going to equal negative I. For 34, I'm going to divide that by 4. It goes in 8, and I have a remainder of 2. So that will give me negative 1. So now we can use those to solve equations, because now I have the possibility of solving a negative number in the radical. So let's try the first one. So we're going to divide both sides by negative 2. I get negative 9 equals n squared. Take the square root of both sides. I now know I can change this into 9, square root of 9 and square root of negative 1. And so I have plus or minus 3, it's the square root of 9, and the square root of negative 1 is I. Second one, same thing. We need to subtract 1 from both sides, so get x squared equals negative 7. Take the square root, and 7 is not a perfect square, but I can take that I out. So I would get square root of 7 and square root of negative 1. So this can be replaced with an I. So the way I'm going to write that is plus or minus I square roots of 7. Okay, the third example, you should have had a number over here on the side, which is negative 56, so add that in, please. And then I'm going to add 2 to both sides. 3y squared equals negative 54. Divide both sides by 3. And y squared equals negative 18. Now I can break that down into the radicals. I definitely think it's easier to use your perfect squares. So you would have square root of 9, square root of 2, and square root of negative 1. I know I can swap out square root of 9 for plus or minus 3. The 2 is going to stay in the radical. It's not a perfect square. Negative 1 I can swap out for I. And then the 2 stays in the radical, just like that. Okay, so sometimes when you see complex numbers, they're not going to be a one-term number like they were here in our example, our answers. They're going to actually be a two-term like a binomial. And you'll always see them in this formation where you have the number in the front, the coefficient in the front. The A value is your real number. And the second term that includes the I is going to be your imaginary number. So for example, if we had the number 4 plus 3I, or the expression, 4 would be your real number, and 3I would be the imaginary number. You know it's imaginary because it always has the I attached to it. So now let's graph. Graphing complex numbers is actually really easy as long as you remember that that first term is the real term and the last term is the imaginary term. And on your coordinates, the x-axis is going to be the real numbers, and the y-axis is going to be your imaginary numbers. You need to clarify that when you're graphing complex numbers, you're only graphing a point, not a line. Okay, it's just a coordinate, not a set of coordinates. So 4 would be, if you want to think about it, this is like your x value, this is your y value. So this would be like your x, and this would be like your y. So for A, I would go over 4 and up 1, 2, 3, 4, 5, and that would be point A. B, I would have negative 2 and negative 3. This one, I don't have a real number in front of that, so I'm actually going to change that to 0 plus 3i. So I would go 0 left or right, and then straight up to 3i. That's point C. And D was supposed to be 4. Got left off there. So that would really be 4 plus 0i. So I'm going to go over 4, 1, 2, 3, 4, and not up or down the imaginary axis because I don't have any value for that. Okay, so graphing them is super easy. Alright, so let's solve our last 3 equations and then we're done. Alright, so first thing I need to do here is take the square root of both sides. So I'm going to square root that, and that would give me n minus 1 here. In the square root of 25, I'm going to change to square root of 25 and square root of negative 1. So I know that n minus 1 equals 5i. Then I need to add 1 to both sides. And I need to put this in a plus bi form. So I'm always going to put the real number first, then the imaginary number. So I would have 1 plus 5i equals n. Let's do that again. So I'm going to subtract 8 from both sides. So I have x plus 3 squared equals negative 2. I need to just take the square root of both sides, which would be x plus 3 equals I square roots of 2 plus or minus, and x equals negative 3 plus or minus I square roots of 2. You should have had a plus or minus back over here too. Alright, last one. This should have been plus 7 equals negative 1. I'm not quite sure why it dropped our numbers off like that, but that's okay. Alright, so first thing I'm going to handle is this 7. I'm going to subtract it from both sides. So I get 1/3 y plus 2 squared equals negative 8. Why did it... Oh, sorry. We're good. Sorry, almost had a moment, but we're good. Okay, then I'm the reciprocal of multiplying by 1/3 is multiplying by 3. Oh, I'm okay. Alrighty, so that cancels out. You get y plus 2 squared equals negative 24. I take the square root of both sides, so I get y plus 2 equals, and let's break this down. So we have square root of 4, square root of 6, square root of negative 1. So I would have plus or minus, square root of 4 is 2, square root of negative 1 is I, square root of 6 has to stay in there, and then I need to move my 2 to the other side by subtraction, so that's going to be negative 2 plus or minus 2I square root of 6. Okay, that's it. See you in 3-5.